Assalamualaikum warahmatullahi wabarakatuh. So today we will do presentation of ISP560 machine learning for shapes classification. So for this project, we consist of 4 members. First is MAISARA binti DELI. Second person is SITI NURJEHA binti PUNGGUT. Third person is INTAN AQILAH binti ZOLKANAIN. And the last person is SYAFIQAH binti Paris. So for this subject, we prepare this video for Sir Muhammad RAZIF bin SHAMSUDDIN, which is our lecturer for ISP560 machine learning for this semester.
Assalamualaikum, my name is MAISARA and I will tell you guys about the introduction of the project. As the world is changing in no time, the system needs to learn on how to improvise things in order to help the people in the future or in the present time. So therefore, we focus on image classification under the shapes of category, which are square, circle and triangle. The system is to learn on how to recognize the picture. We have chosen a dataset from Kaggle with 200 observations, and 180 of it is the trained sample, while the other 20 is the test sample. The importance of doing this project is we realize that every person is not the same, and we do not produce the exact same handwriting, and it is crucial for the system to know the differences, and it could lead to beneficial things in time.
Assalamualaikum, my name is SYAFIQAH and I'm going to explain about data analysis from the dataset that we have chosen. Our group can analyze that the dataset contains 200 data in a format of pixel. The pixel is about 28 times 28, then we should have 784 as the input for the input layer. The train set for the dataset, we use it as 180 train set. The test set is also 20, so the total of all is 200. The pixel is provided with a number of range 0 to 255 RGB, where 0 is black and 255 is white. We process it into the image and turn them into the grayscale format before processing it. Before we start processing the images, we convert it into the grayscale because it is easier to read. The pixel then will be turned into binary format.
For the coding made for this project, first and foremost, we need to load the datasets from Kaggle by using the import function. We import several libraries such as NumPy, Pandas, Matplotlib, and Seaborn. Next, in order to use the dataset, we need to read it into the system, and the output produced are shown in the screen. The shape for this dataset is 200 rows with 785 columns. For the length function, is where we want to know further about the dataset length, and the info function will print the summary of the dataset. For us to know the images and the shapes provided in the dataset, we import the images and plot it by using the fixed size to 5 times 5. We want to print it by 3 in rows and 3 in columns. The ilog function will give us the Pandas series of data frame from column 1, and we change the type to float and integer. Then we normalize the data and reshape it from 748 into 28 times 28 in size format.
For input 13, we import train test split from sklearn model selection. This train test split is a function in a sklearn model selection for splitting data arrays into 2 subsets, which is one for training data and one is for testing data. And then for input 14, we import keras from TensorFlow because we want to use a function keras.model.sequential, which will provide the training and inference feature on our model. And then we use model.summary function to output the number of total parameters, the number of trainable parameters, and the number of non-trainable parameters in our model. On input 15, we use model.compile function to compile a model to use for our graph. And then on input 16, we use a list stopping function that we import from TensorFlow keras callback to stop the training when a monitor metric has stopped improving. So next is where we use a model.fit to measure the model generalized to simulate data to which it was trained. So this is where we train our data. So and then we put the epoch, we set the epoch to 30. On input 18, this is where we evaluate our model, and it will output the graph summary after fitting the data. And then next is on input 19, it is for printing the valid accuracy. Next, on input 20, this is where we use function to predict our model, and then we convert it into the grayscale format because it is easier to read, and then the pixel will be analyzed and turned into binary. In input 21, this is where we label our model. So we have 3 labels here, which is circle, triangle, and square. The predicted label is 0, 1, and 2. And then on input 22 is where continuing the prediction of our model. And lastly is we use classification report that we import from SKLA matrix. This classification report is used to measure the quality of prediction from a classification algorithm that shows the main classification metric precision, recall, and F1 score on a per class basis.
To continue the presentation with some experiment that we did. We did 4 experiments here, and this is our model evaluation in terms of graph. It makes it easier to understand. Okay, in experiment 1, from the plot of loss, I can say that there's no much different, but in accuracy graph, we can see that the model has comparable performance on both train and validation set. And I can see that in experiment 1, the graph shows that it has low loss and less accuracy. And moving on to the experiment 2 with learning rate of 0.02 and alpha rate with 0.2. And as we can see here that towards the end of the training accuracy, it stays at 0.45, and it is lower than the validation accuracy. And for the training loss, it is slightly higher than the validation loss, which is at 1.07, and the lower the loss number, it shows that it is a good model. In experiment 3, we set the learning rate with 0.03 and also the alpha is 0.3, and we can see from the plot of the loss graph, we can see that it has higher loss and the accuracy stays at 0.45. And in experiment 4, we set the learning rate with 0.04 and the alpha rate with 0.4, and the loss graph has higher value and the accuracy also stay at 0.45, and there's no much difference between the experiment 4 and experiment 3. And I think the best model evaluation through all these 4 experiments is experiment 2, where we can see that it has low loss and higher accuracy.
So this is the coding for our model summary. We use dense and then flatten to flatten the images from 3D to 2D images, and this is how we do the model summary for our neural network architecture. Okay, so this is our model neural network architecture. So from input, we have 128 nodes, which produce from 28 times 28 images, 2D images. And then from input to hidden layers, we only have 64 hidden layers, which produce 8,256 weights. And then from hidden layers connected to output, we only have 3 unique outcome, which is circle, triangle, and square. So for output layers, we have 95 nodes or weights. Okay, so for the result, in terms of response time, we use Anaconda Jupyter Python to train and test the data. Second, the accuracy of dataset is 90 and above %. The response time differ from every process, and it almost took about 1 hour maximum. Second, in terms of memory usage, so for this dataset, Anaconda Jupyter optimized operation as the usage for memory are less than 1.2 megabyte or for all documents related. And third, in terms of number of epochs, so we have experimented using only 30 numbers of epochs, and the network reached 96% accuracy in less than those epochs.
Through this project, we can see more clearly about the advantages of using machine learning to produce an accurate result for classification. We learned that when we use many epochs, it could produce better information in terms of output and result. We also learned that trying different methods could bring the best and accurate shape recognition. Through this experiment, we also faced some difficulties such as time consumed to produce each result. To gain an accuracy of nearly 90%, we learned how the performance increased the accuracy of every epoch. Even so, we are very glad to master up this process to gain an accurate result for this project.
So as for the conclusion, we have introduced a new way for integrating shape and classification into a single learning scheme, rather of depending on handcraft or engineering matching functions. We use structure estimation to learn point matching measures with the goal of minimizing classification loss. Our method can be used to improve any correspondence-based form classification system. So the dataset gives us to classify 3 shapes, which are circle, triangle, and square. With from all those, we are able to identify all the shape using Python and integrate into 2D images.